Hi everyone, my name is Dr. Siddharth Prakash at the University of Texas Health Science Center at Houston. I am here going to tell you about a new research project that we're starting to understand why people with Turner syndrome are born with certain types of heart and blood vessel problems. My co-worker in this effort is Dr. Casey Gifford at Stanford University, and she contributed much of what I will be describing. A little about me. I'm a cardiologist in Houston, Texas. I've been long interested in genetic causes of bicuspid aortic valve and other kinds of heart and blood vessel problems that are related to bicuspid aortic valve. And I'm co-director of our adult Turner syndrome clinic, along with my colleague, Dr. Michelle Rivera. We see patients from all over Texas and the surrounding states. We set out to answer a few research questions that came about because we wanted to learn why certain types of heart and blood vessel problems are so common in Turner syndrome. For example, do some or all cells in the growing embryo need to have two X or Y chromosomes in order to form a normal heart? And which cells in the embryo actually need these chromosomes to function normally? What is the lowest percentage of cells with two X chromosomes that are needed to form a heart, or an X and a Y chromosome? We also know that not all people who have 45X karyotypes in their blood cells have heart problems. So what other factors besides having a 45X karyotype are needed to develop heart abnormalities in Turner syndrome? To answer these questions, we developed a method in our laboratory to create stem cells from Turner syndrome patients. This slide shows you how we do it. Using a regular type of blood draw from a person's arm, we can take peripheral blood cells and through a process called reprogramming, turn them into stem cells. These stem cells are pluripotent, meaning that they can turn into any cell type in the body. Through a process called differentiation, we can order them to become cells that we want to study, like heart valve cells or heart muscle cells. We can also use a different kind of method to create organoids, or miniature organs in a dish that we can study to learn how organs develop. In this case, we'll tell you about a process that we use to create heart organoids. If we combine cells in a certain way, we can form a beating heart in a dish. The heart cells have all the different types of cells that we see in a normal heart, but they form in a matter of days instead of weeks or months as in a developing baby. If we take cells from people with Turner syndrome who have mosaic karyotypes, the cells in the organoid that we are studying also have mosaic karyotypes. This allows us to determine what mix of cells is necessary for a heart to develop and what type of cells in the developing heart function normally or abnormally in Turner syndrome. This project is just getting started. It would not have happened at all without the support of several people that I want to thank. In particular, Stephanie McDaniel and the Graham McDaniel Foundation, Cindy Skurlock, and the Turner Syndrome Society of the United States. With their support, we hope to have answers to our questions soon and be able to share these with the Turner syndrome community. More importantly, we think that these answers will help us to develop new treatments for heart problems in Turner syndrome in the future. Thank you, and please participate in these and other studies on Turner syndrome.